Hello, Kurt.
What's up, Lucas?
This is our third conversation, isn't it?
It is, yeah.
It is, yeah. I'm really looking forward to this. Just sharing with you and the audience the rough plan for today. My hope for today is that I've kind of tried to integrate all the things I've learned through you into drawings. So through you and the things I've read and stuff to really answer the fundamental questions of Bitcoin. And I will try to present, this is what I've come up with. You can tell me, are there any mistakes I made? Because I'm sure there are. But beyond that, you can then just take that and run with it, because I imagine you have so many more interesting things to add. But then we have kind of a rough orientation, which is going to be this. Do you like that I made it kind of a Bitcoin there?
That's beautiful. I love it.
It is super, super pretty. So the rough orientation is going to be the questions of, number one, what is Bitcoin and who created it? And I'm going to try to give a concise overview of that. How does Bitcoin work? Because I think we can't really understand what Bitcoin is before we understand how it works. How many Bitcoins exist, which goes both into like different Bitcoin forks, but also the kind of just hard facts around it. I have one that's called What is the History of Bitcoin, in which I'm happy to look at things like how did BTC start? How did it then fork into BCH and BTC, just so people can get a rough overview. And then for me, the most interesting one is actually getting to why Bitcoin, which to me is what are the things we can do with Bitcoin. So that's the rough overview over today. I don't know if we get to all of that, but that's the idea.
Okay. We could try.
Yeah, let's do. So I'm going to start off with what is Bitcoin? And the first thing I want to note is that most of the time when I listen to especially like BTC podcasts, there is a lot of talk about Bitcoin, but nobody really talks about what it actually is. It's more looked at it as, wow, it's a great investment. And wow, it's the greatest invention ever. It's a scam. And it's more these like tags rather than actually looking at what it actually is. So that's just one of the things I find really interesting. But when I try to answer what is Bitcoin, the one thing I can come up with, it is very clearly an invention by this, whoever it is, Satoshi Nakamoto, and it was published roughly in 2009. It was published both in the form of a white paper that is still being talked about quite rigorously in certain areas of the Bitcoin sphere, and of a SourceForge.net. I don't even know what this is called. It's a hub.
It is a Git. So it's a Git control, basically. So an open source development repo. So every proposed change is organized.
So these were the main places where it was published, which is interesting because nowadays Bitcoin is not on SourceForge.net anymore, but on GitHub, which is a very interesting fact. And as far as I understand it, Bitcoin was basically a solution to a question, which was, how can we secure transfers of cash, that's the coin in Bitcoin, and data between users without a central controlling financial institution like a bank? The most obvious problem in that would be that if we just let people do whatever they want, there would be double spends, people would spend money they don't have, etc., etc. How can we solve this problem with the additional fact of how can we do that not just for big payments, but also for micro payments, which is something that the white paper talks about quite in detail. We need micropayments. So basically, what was published with Bitcoin is kind of an answer to how can we do cash payments between users with a secure record minus the bank. And in one way, Bitcoin is actually an answer to that very fundamental question. That would be my overview of what is Bitcoin.
This is brilliant. It's very well put.
Wonderful. So I imagine there will be times when I have more problems, but basically for this, the question is what was invented? Bitcoin, what was invented is a set of rules. And I talked to Bernhard Müller about this last week, and he was like, Yeah, ish. So there are these supposed rules, but nobody ever wrote them down. So there are kind of fights around what the actual rules are and how they were meant to be and all of that. But
Sure.
in theory, Bitcoin is a set of rules, what can be called a network protocol. And these rules allow the creation of a network that then allows the use and the security of a peer-to-peer electronic cash.
Yes, I think that's to the point that you mentioned about the rules. Some are actually ambiguous. However, some are very clear. So a really good example of this is the finite supply. This is something that's talked about quite a bit, is that the white paper talks about the auditable supply, that you can check it out. This is also one of the very first thing, it might be the first thing that Satoshi ever said when he debuted it, is that the supply is fixed, it's auditable, the world can see it. But what he didn't specify was what that supply was. So he didn't clarify that. He didn't let anybody know what it was going to be. So people discovered this when the first issuance of the software was shown. And people are like, okay, it's 21 million. But before that, so then it's interesting because it's a curious concept. It begs the question whether, was that number arbitrary? Was that number thought of when the paper was written or that kind of thing? But so when people say, well, I don't know if it's a rule or not, well, I think it's pretty clear that the fixed supply is something that Satoshi obviously cared about. He wrote about it multiple times, multiple ways. And then when he issued it, that's when you discovered what that fixed supply was. And so, but this is debated in some circles, hey, maybe we need more inflation. So this is why there are altcoins that have endless inflation, for example, that there's just always going to be an emission that makes sure that the network is always secured by people that want to mine for a block reward. So I think it comes down, first of all, to a philosophical definition of what a rule is. Like, what is a rule? Well, this, and then this has an east-west problem and a benefits versus morals versus, all kinds of things. So I think Satoshi Nakamoto is very clear on what the rules are. And there is some debate that is intended to be gray also. So there is the complete stack on top of Bitcoin that is still largely unexplored. You can build all kinds of things. I mean, people may come up with things to do in the Bitcoin stack that Satoshi never envisioned, because it's basically
when you mean the stack, it's the possibilities of how you can use the network, how you can use the implementation.
Yes, it's essentially operating system probably isn't the right word to a software engineer. Like they will eke when I say that, but I think for somebody that's not a software engineer, I think is probably the best way to describe it, is that there is an operating system built on top of Bitcoin that allows you to use the op codes or operation codes or operator code. Now I'm going to screw it up, but
Just say op codes.
They're op codes. Satoshi called them op codes. So, but what it allows you to do is create ways to manipulate things within transactions, but up above the transaction, essentially. So there's a second layer, similar to how the internet has low-level protocols and higher level protocols, and people like me and you interact with the internet using TCP/IP and things like that. Like, this is the basic internet that we see, but there's all kinds of parts of the internet that you and I don't have a way to browse. And I think that Bitcoin will eventually go that direction, where people are interacting with something higher up in the stack that is retail friendly and works like we picture the commercial internet working today. And in that, then it's to say, like, well, what is Bitcoin for? What are the rules? And it's like, it's a general purpose system. Just builds. Like, don't break the rules of the network, but build whatever you want. Inside the structures, there's infinite possibility. So humorously,
so that's actually a really interesting perspective to say. What was published was this white paper kind of outlining what's Bitcoin supposed to be. There was the published software, but that was about it, and the rest was go figure it out. And the software contained lots of implementations, and some of which were kind of examples of how Bitcoin could work, and others were hard coded. This is the groundwork, and people had to figure out what is an example, what is the foundation, how do these things play together, and people are still trying to figure out what can we do with this thing. And as you said it, that people are probably just starting to scratch the surface of what's possible using that weird thing called Bitcoin.
Yeah, for sure. Perfectly accurate.
Yeah, so this was just in my conversation with Bernhard, because I mean, he's Swiss, so he kind of has that more Germanic mindset. It's this like, but what are the rules? Sure. Where are they written down? Which has its own very wonderful perspective, but there's also just do things.
No, for sure. I mean, there's a reason why there are great German race cars, but you want an Italian race car driver usually. So, but I mean, all that to say that, yeah, I mean, within those structures, like this is why economies work. Economies work because there are people who are systematic, and we're going to build in, okay, here's how we make the road safe and all these different things. And then you get the wild man who's like, well, yeah, but if I get enough terminal velocity, I can actually drive up the wall. And, and it's things like that become, they become ubiquitous. I think a really good example, if you go way back into prehistory, there is some old art from when man first started to ride horses, and they rode horses differently than we ride horses today. They actually rode over their hips. So they were sitting on the hips, like right near the butt of the horse. And this is just some early cave paintings, and they're not all in one place either. If I recall, and I could be wrong here, but if I recall, it was they're basically hieroglyphs from the Russian steppe, and they were likely Mongols, and they're sitting on basically the butt of the horse, which is really inefficient. It doesn't make any sense. But the reason is that they looked at it and they're like, well, I mean, that's the highest spot on the horse that we can, maybe this makes the most sense because we have the most elevation and we can do whatever, until someone, like there was some soldier at some point who made his way 2 feet forward and said, actually, this works better. And then since it worked better, this became the universal way to ride a horse thereafter. But we don't know how long people might have ridden horses wrong for hundreds of years even. And so there's things like that where, you get the engineer mind, the people that want to be the controllers, the perfectionists, and say this is correct because of, math, science, and my brilliance. And then you get the person in the field, the person with experience, and they look at things and say, I've got 10,000 reps on doing it your way, or, however you engineered it, but I've discovered, and then it's something. And we see this a lot in like sports science, and we see this in engineering for, medical equipment and technical equipment. And we see it in things like, even civil engineering and things too, like how to make somebody stay at the shopping center by the way that you design the parking lot, and like
how to make people stay at casinos.
Yes.
Like that's I find that even crazier, because you intentionally take away daylight, you intentionally don't have clocks anywhere, you make everything like a maze. It's actually horrible to think about the fact that there are people whose main job it is to keep people that are probably addicted in the place that they're addicted to.
It's an incredible feat of social engineering. It really it shows how brilliant. I mean, like, take the morality out of it. It's the machinations that a human can come up with to, treat people like cattle essentially, and it works very much the same way. Like you figure out the pecking order of the animals, and you figure out how to make them efficiently live their lives because they're part of an efficient system. it's a little bit of a creepy way to look at it, but a casino or a shopping mall or all kinds of things are actually very similar concepts.
Yeah.
And yeah.
So then let's maybe look at the Bitcoin concept a little bit more, because we've kind of looked at what was the Bitcoin invention. And I would love to now look at, so we called it a network and a network protocol and all of that. And I would love to take a few steps understanding how does that network work? Like maybe in the example, what are the ground rules that where then people can innovate, and what's kind of the game that Bitcoin allows us to play? And
I think that's the best word to start with. What is the game? Because I think that's a big part of it.
I actually will use a metaphor of athletics when I try to explain the miners, because I think for me it's the smartest way to think about it. So we'll get there. But so I think one way to understand the network is by looking at who's participating and what are the rules. And this is where I've learned a lot from Connor Murphy. He has great videos on this. So basically, there are 3 types of users roughly in the Bitcoin network, and one of them is not really developed very much yet. And the first user are the just normal users who send each other payments. So I can send you a Bitcoin payment. Depending on which Bitcoin version I use, I can send different amounts of money, but I can send you and I can send my mom some Bitcoin and I can receive Bitcoin and all of that. That's the user level. Then there are the nodes. They are often called miners, but I actually prefer the word nodes because I think miners actually brings up a lot of ideas that are not very useful to understanding what they actually do. But nodes, which are basically there to check the transactions and see, are these transactions good? And when they've checked them, put them in what's called the public ledger. So they basically make a timestamp. They basically timestamp them and make sure this is the book I'm keeping. And then the third field would be merchants, which is hopefully what's going to develop on Bitcoin, because that will actually make it usable, which is the system where where many users interact with merchants to buy, to sell, to transact, to have a social network built on Bitcoin, whatever. And these merchants then have intimate relationships either with one node or with multiple nodes, and they are kind of an intermediary between these. So these are the 3 users, but let's take it one step at a time. Let's focus on the users in Bitcoin. And as I said, these are the ones that basically do this thing called sending transactions to each other. And the very simple thing would be, you can send whatever amount of Bitcoin you own to another user, and you can attach data to it if you want to. This data can be data about you as what's your user data. It can be, you can send a picture with it. You can even send a video with it if you want to pay ridiculous amounts of money. You can do all of that. And the way that happens is like this, and I've tried to draw it out so that people can imagine this. So this is me. I am A, you are B, as is obvious.
Perfect.
I have 1 Bitcoin, and I can basically send that Bitcoin to you, which within the Bitcoin sphere means I have a wallet that runs a Bitcoin software, where I can have access to the network. For this wallet, I have what is called a private key. This is kind of my secret, nobody knows what this is, identifier of this wallet is mine. And I have what is called a public key, which is where I can interact with other people. And through my wallet, I can send the Bitcoin to your wallet. So you must have a wallet on the Bitcoin network as well. And more specifically, I send it to your public key. I don't send it to your private key because I don't know that one. I send it there. And if you want to, this is actually in my wallet. I have these And this is where one of the Bitcoin talks with Craig Wright and Charles X. There's another name there.
Ryan X. Charles.
Ryan X. Charles,
yes.
Where he describes it as letters being sent to a letterbox, which makes a lot of sense to me. So basically, my Bitcoin is not just laying randomly in my wallet, but it's actually laying in what is in Bitcoin called a UTXO, an unspent transaction. I've once received that transaction and I haven't yet spent it. And that transaction is locked with a locking script. So that locking script means not everybody can just spend this Bitcoin laying around in my wallet. I have to prove that I am allowed to spend it, which I do with my private key. But when I can prove that, I basically send it to your postbox and it lands on your private key. So your private key is kind of like a postbox.
My public key is like a postbox.
Public key, sorry. It says
yes.
Public key. I said private key. So in a nutshell, that's kind of how it works. And if we want to break that down into how I do that is I have this Bitcoin. I want to send it to you. For that, I need your public key, your postbox. I need to prove it's mine, for which I need this private key. I send you one of my Bitcoins that is in this UTXO. It goes here in a new letter. So then it's one of your UTXOs. And I send myself the other one so that I have it back in my wallet in a UTXO. That's basically how I understand transactions to work within Bitcoin.
Then you understand Bitcoin transactions better than almost anyone. This is a very, very good analysis. So far, I'm very, very impressed. I love this.
Okay, now I feel a little bit shy, but that's okay. I can deal with that. So having that just one last point here, I have this UTXO. I basically sign it with my private key saying I own this, I'm allowed to spend this. This one then gets divided because I only want to send you one of my Bitcoins. This one gets sent to you in the UTXO. So it lands here, and the other one gets sent to myself, to my own public key, and it lands here as its own UTXO. That's kind of the way the Bitcoin transaction works in one picture.
I think it's very good.
Okay. Bernhard again told me there are so many more types of transactions that people can do, but as far as I understand it, this is like 99% of what is done nowadays.
Correct. These are the most simple breakdown of what a Bitcoin transaction looks like. There are ways to build special transactions. For example, like the way that we do tokens right now is even optional. So a lot of people will do tokens up in the stack in the opcodes. They'll put like right now the most popular way is using the Run protocol. Run protocol uses JavaScript. So they put a piece of JavaScript language up in the op return. So there's like a bucket basically that is attached to transactions. And in that bucket goes JavaScript that can then be decoded into all kinds of other things. It can be Lucas token, or it can be some NFT, or it can be it can even be a tokenized, individually serialized piece of dancing digital art or something. But they're very, very flexible because JavaScript is very, very flexible. So when you send that
maybe in this picture, it would be, it's still a letter, but it's attached to a package now. And in that package, we can put different things.
Correct. That would be a great way to put that. Secondarily, and this is done less today, but a lot of people believe it will be done more in the future, is doing a UTXO level token. So using the native script, and this is a little bit above my pay grade because it really hasn't been explored by almost anyone. So I'm trying to explain something that even the experts have only lightly tested. But you can encode into the transaction various commands in the transaction that tell the UTXO set to lock up some of the Satoshis that you are sending and collateralize them into another token. So this would be a token that actually has Bitcoin weight to it, rather than just the existence, whatever the cost was to mint the JavaScript-based token. Those are just burned, not burned, but they go to the miners, they go to pay whoever, the computational cost. But in a STAS-style token, or old school Bitcoiners might call this a colored coin, which would mean like taking a Bitcoin and painting it purple so that it always stands out across a ledger of otherwise yellow Bitcoins. And so what you're doing is you're locking them up. So you're actually creating a value floor to the token that you're creating. And then you transact them the same way that you would transact Bitcoin. So rather than using the JavaScript or up in the stack, you're actually making a transaction for every use of the token. And so the reason people like this is it then makes your token as secure as Bitcoin itself, as opposed to something in op return in theory can be pruned. Like a miner can just say, you know what, I'm just not accepting the package, basically. Like I'm gonna take the label, but I'm gonna reject for the package. Correct. So if you do a STAS token, it's sort of like stuffing the tokens into the envelope and putting extra stamps on the envelope. So this is a STAS token.
This is where we actually get into all the possibilities with tokens, and there are many, many, many possibilities. But it sounds like one possibility to have tokens is tokens are in here, and then they kind of lay not really on the Bitcoin network, but they're attached to it loosely, and that way we can still prove transactions of tokens because of it needs a transaction of Bitcoin, but it's not in the network itself. Whereas if we took a Satoshi and we painted it, then that token could never be transacted and never be moved without the involvement of the Bitcoin network, which would actually make it inherently more secure.
Yes.
Okay.
But even those two things, like this is just tokens. So I just gave you two other types of transactions, but it really could be infinite, frankly. If you're a miner, if you're a node, if you're running, the full software and you're able to do anything you want, you can program all kinds of things. And in fact, there was a debate about the zero sat, zero fee, where you don't move the UTXO set at all, but you are using the network to generate. So it's even debated, would we even call that a transaction actually, because you didn't move the set. And Craig Wright stepped in to say very, very harshly, no, that is not, it's not good, but it is something that you can do. So this is an example of, a transaction type that is, you've conjured something. This is magical Bitcoin, basically. But again, then there's thousands of other. Sorry, go ahead.
Yeah, no, it's just that even just by opening up that you have a transaction on Bitcoin that is not actually a Bitcoin transaction, it gets very what?
It's kind of like I can't remember what they call it's an old hacker term, but you used to be able to hack the payphones by using certain tones. And this is obviously not what the phone company intended for you to do, but there were people that were using Morse code and certain a certain tone, because the way that the old phone switches worked was based on the pitch of the sound that was going over it in order to know what numbers were being pressed in order to indicate payment. So you could hack the toll-free part of the network if you knew the tones that were used. And then rather than using your voice over it, because people were concerned that they would be recorded and then, therefore in all kinds of trouble, they would just use Morse code and just use the one button and sit and tap messages across to each other. And this is an obvious hack of the network. This is not how it was designed to be used. But,
it works.
They looked at it and said, well, we're able to communicate for free over your network. So you start to get into some weird legal gray area, because it's like, well, the terms of service don't say that I can't do that. Like, did anybody indicate to me that this was not how this machine was to be used? And so that it starts to become like, okay, I guess we got to break down like who owns the network, who paid for the network. And when it comes to like, well, some of it was paid for with public funds and this and that, it becomes very, very bizarre. And I would expect
yeah,
I would expect there to be quite a bit of that on Bitcoin going forward, because the terms of service, you can't have terms of service that cover every single possible reality. And so,
and the more creative people get, there will be more and more weirdness being tried, whether that's zero Satoshi transactions, whether that's some weird transactions that allows certain things to happen where everybody's like, is that still what we're doing here? Which right. I think brings us to the next point of the Bitcoin network, because then we actually get to the question of who then decides whether these things can happen or not. And I think that question is very close to when we have users sending money to each other or Bitcoin to each other. How do the users know whether the transaction they received is valid, that it wasn't a double spend transaction, that they now own it, and that these are real tokens or real Bitcoins that they're receiving, and that the rest of the network has accepted this transaction? Because that's usually what banks do. Usually it's, I send you money and it goes through my bank at home. My bank says, yep, he has that money. It goes to your bank and your bank then tells you, yep, you received that money. So usually there are actually two banks in the middle here that make it possible that we can send money to each other. But on Bitcoin, these two banks don't exist. On Bitcoin, there's only that weird network. And Bitcoin actually came up, and I think this is, for me, the most fascinating part of the whole network, is the solution to that problem, which is that in Bitcoin, there are these transactions, and it's actually verified and timestamped by the nodes. So it's the nodes that decide, is this a valid transaction? Am I allowed to send you this? And did I not send it before, etc., etc. And the nodes then verify and timestamp, so they also account for it. And I think the best way to think of that is, so number one, visually, users, but there are also these nodes that then check all the transactions happening. I think the smartest way to think of this is kind of a network of its own. And the nodes are mostly interacting with other nodes and not so much with other users. And I think when we can get that into our mind, then actually a lot of things get a lot clearer. Because I look at it as the users are playing one game, but the miners are playing a completely different game. It's just that they're kind of the referees for the users.
Yes.
And I like to call them nodes because actually I think the word miner just makes it sound that all they do it for is for the block reward, when actually the possibility, and this is something that happened on the BSV chain just recently, the possibility for miners that the more people use Bitcoin, they can make way more money just with their role as nodes rather than the block reward that is sent after them. I think the block reward was more of a incentive to get it started. So I like the word nodes more. And I think miners actually has this, oh, we're looking for gold and kind of thing to it.
That's exactly how Satoshi saw it. I mean, he used the node, the word node to describe the entire process of transaction processing, mining. Like mining is a subset of the job that a node does. And so BTC people, the small blockers, broke it out. They break out the different roles, but they do them bizarrely. They break them out so that they can make the individual parts smaller, which I think is a very weird thing to do. Rather than allowing them to specialize and optimize, they break them out so that they can be kept in separately small boxes. So a node.
Can you explain that? What's being kept in boxes?
Yes. So there's a number of functions of a node. Transaction validation is one of those things. They check the supply, the rules, everything else. Like, is this in consensus? And if the answer is yes, it will validate and pass it forward. It is just a peer, so it's just a pass point. But a node also has this ability to hunt for hashes, and if you can hunt, if you can find the hash that is being asked for by the network, then you are the node that mined the block. But they've separated that out, and it made sense to separate it out. Like mining pools, for example, are something that Satoshi envisioned. So he envisioned a node that was collecting hash from, it didn't have to be physical. It didn't need to be on your local area network. That you're in Germany, if I recall. You could have an ASIC machine that connects directly to my node here in Florida, and you can mine on my node, and I distribute the reward that you have mined
BTC
relative to the hash power.
Yeah, BTC basically separated the transaction verification and the hashing, the mining itself, basically.
Yes.
Okay.
But that's so. And that was all well and good, but then they created this system where an endpoint. So this is like, if you're in IT or sort of cybersecurity or networking terms generally, what they have done is they have redefined the word node to an endpoint, which would be any IP address on a network. So your laptop is an endpoint on some network right now. So is your cell phone. So it would be your Netflix if you got a dongle or whatever that connects your TV to the internet. But endpoints don't do anything except to receive and maybe pass data back. But they're innately, by definition, a very small thing, or they can be a very, very small thing that just receives packets of data and can pass them forward. And so that is not a Bitcoin node. I think the right word for them is endpoint. But in BTC, they say that a node is anything on the network that sends and receives data, regardless of what function it does. So even if it is incapable of validating the block inside of 10 minutes, much less mining a block inside of 10 minutes, which 99.9% of BTC endpoints are not able to do. So they've created this subset of nodes and created their own definitions for the terminology of things, and created a network that is not like what you described in your picture. I think you have 4 nodes in the middle of your network. But what they've done is they've treated every user as a node and node as a user, and said, if you're not using a fully validating node or whatever they want to call it, then you're not actually a user. So that somebody with a light wallet, for example, like a cell phone wallet, isn't actually a user participating in the network. So they,
according to their definitions,
their redefinition of the network itself. So they have a very different view. And what their view has done is it's created a massive Sybil attack surface. So what a Sybil attack is it's a dishonest node. It's a node that says, hey, I'm a trustworthy governing member of this system. And when you ask it for proof, it says, look at me, I'm beautiful. Like, that's the response. And it's like, well, that didn't answer the question. Like, this is innately deceptive. And so what they do, this is one of the very first things that changed in the history of Bitcoin after Satoshi left. So this is in, I want to say it was 2011, that they created a flag signaling system and the BIP process. So a BIP is a Bitcoin improvement proposal, meaning that in the GitHub, now developers can say, here's how we should change Bitcoin. But here's this problem. The honest nodes of the network don't want to change Bitcoin, and they're the gatekeepers, they're the referees. But we want to change the rules of the game. So let's let anyone who runs a $60 little endpoint and call it a node, because the white paper talks about how nodes govern Bitcoin. So we'll call them nodes because they're, people don't understand the topology of the network anyways. And then we'll let them vote by simply holding up a yes or no flag. So it's green or red expressed in code. So what they do is say, like, basically thumbs up, BIP number, whatever. And if a majority
we want this change.
Correct. And so rather than validating rules by building blocks that have valid rules, then all they have to do is their signaling. So they have turned Bitcoin from a proof of work governance network and turned it into a social democracy. And the value of that can be debated, but it's not Bitcoin, in my opinion. That is essentially a coup d'etat or a revolution. Like, you have overthrown the governance model by a populist vote of, yes, but we can do what we want because of our node, and my node signals this. And so it is essentially tearing up the constitution and changing the governance model.
Yeah, which if we go back to this perspective of what nodes are, because the white paper does say that the nodes are responsible for what's the word? For consensus. That's the word I was looking for consensus on the network. Yes. And we can of course say, hey, we have these BIPs, and then we have a vote on it, and then we have consensus. But the way I understand it, that consensus, as it was written in the white paper, was actually meant as a very different type of consensus. And maybe we can get there just now. And then I imagine the place we're at right now, we can even expand upon. Because as I was just trying to say, so the nodes, or the miners, the nodes are playing a different game than the users, and their game kind of makes them the referees of the user game. But the nodes themselves have kind of their own athletic competition, which you could call a computational pentathlon. So they have this competition going on with each other that has very, very specific rules. And their competition is based on, number one, receive as many transactions as possible. So each node is trying to receive transactions and then to validate or verify them. This transaction that I received, is this a valid transaction? When they have verified it, they will take it and timestamp it and then account it into a pyramid shape that is also known as a Merkle tree. So they will basically take all of their transactions and make this, and then they combine these two into the next hashes, creating this tree that in the end has one hash on the top of it. That's called the Merkle tree. Then once they've done that as quickly as they could, that's why it's a pentathlon, they perform useless math magic on that top hash, because literally that hashing doesn't do anything. All it does is it makes them work really hard to receive this new, this double hash for here that is according to some strange rule that they've made, which is called this nonce, which is like this double hash has to be this difficult. And then they go like, oh, fuck, that's pretty difficult. And they work as hard as they can. And then when they have found that double hash, they share it with all the other contestants. So all the other nodes will look at that as quickly as they can. If they see, wow, what you did is correct, they are fair sportsmen and they say, you are the winner, you win this competition. But they don't say that by giving them a pat on the back or being like, you're awesome. But actually what they do is they accept the block, the hash, as quickly as they can and start building the next block on top of it. That's all they do. And they will try their best to find a mistake the other node made, because that means they still have a chance to win. Because if I can prove you made a mistake, I can still beat you in this athletic competition. So that's my understanding of the computational pentathlon that nodes have with each other.
This is, again, a very good example. This is very concise and thorough at the same time. So it's a very good way to put it. If I were to add anything to it, it's that there is also the excess of computational power that is created, or the opportunity that is created to do all kinds of other stuff with all of that power that has been gamified by this competition for the hash, that then allows Bitcoin to be a distributed supercomputer. And this is what's running the stack that I mentioned too.
You never know what's around the next corner. So.